Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap. I'm really excited about this one, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Discover How Volvo Cars uses a time series database to become data-driven, or InfluxDB and TickStack at Volvo Cars. Our speaker today is Maksim Puzykov, who is a DevOps engineer at Volvo Cars. Maksim, thank you very much for joining me today.
Thank you. Thank you.
You're welcome. I'll put myself on mute, let you get right into your presentation.
Thank you and welcome everyone. I'm really happy to be here. And yeah, my name is Maksim Puzykov. I work as DevOps engineer at Volvo Cars, and my focus area is monitoring systems and a little bit of automation. I used to work with enterprise management systems as well. And today I'm going to talk a little bit about how we changed in our organization and how we changed in our team, how we changed our scope to become more agile and DevOps oriented, to help organization and our users to act fast and be as much as possible productive, and to support them in this journey, in the transformation journey, in digital transformation journey. So we used to use the classical monitoring solutions like Tivoli monitoring, and if I go back in the past, it was a Tivoli Framework and Enterprise Console. And recently we changed to new stack of technologies, or not that everything is changed, but we are on this change right now. And now we have Grafana and Elasticsearch in our portfolio. We also have Influx as a metric monitoring solution as well. So the question is why? Well, there is 3 main reasons why we had to change. And during the past time, then we used to provide monitoring services for our organization, we faced a lot of, or maybe not a lot of, but some kind of challenges in the monitoring setup. And one of the biggest challenges, it was transparency, low transparency or visibility, because quite often the organization, they will use their own setup, they use small dashboards, and sometimes it's not very easy to display the health in the dashboards. And nowadays, then you have a lot of changes in your environment. It's also hard to update and keep updated dashboards and alert rules. And the low transparency will lead to another problem, the non-collaborative mindset. You know the story, like then you have some issues and the metric not received from the host, for example, or from application. The teams or users, they tend to say, okay, it's not our problem, it's something on our other side. The hosting team should fix the agent, or monitoring team, they should fix the thresholds and alert rules. And because of that, the coverage or quality of the monitoring was pretty low, because a lot of these pinpoint actions. And the last point is the self-service, lack of self-service. We used to work in a, pretty classic way. We used to have the change requests So users, if they need to change some monitoring parameters, thresholds, or change dashboards, they have to write a ticket or change request. Our team used to receive this request, process it, approve it, then implement the changes, and then finally, after some time, the requester will get a new dashboard or new monitoring rules in place. And it's too long process. So we have to do something to address these three main problems: transparency, mindset, and self-service. And in order to answer on these questions or challenges, our monitoring team, the monitoring management team, was transformed into something new to help organization in the transformation towards Agile and DevOps. And we become DevOps Enablement team, the special team who is help other organizations or business units or other teams to be empowered, autonomous, and digital. Meaning we provide tools, a different set of tools for our internal customers or users to make them autonomous as much as possible, to let them control and operate everything they need, including monitoring solutions. So again, DevOps enablement, now we called it like this, and it's all about people, processes, and tools. So from our side as a team or our organization unit, we offer technologies, we support our users with ways of working and thinking to help them be more agile, to help them in this DevOps transformation journey. And we offer basically not only monitoring solutions, but all the components or elements needed from planning to release and operations. And we form basically four principles. The first principle is best of breed. After some time learning, trying, we found like we could do better, with more efficient and cost efficient if we use the small solutions, maybe not small solutions, but some solutions which will focus on the certain area, on the specific problem. Let's say Elasticsearch for log management and Influx database for metric monitoring and analytics, because it becomes quicker and easy to maintain, and maybe we can solve the problems better if we compare it with some monolith, the big solutions which aims to solve many problems at the same time. And we of course integrate these solutions in something special we need in our organization. And because we use different solutions integrated each other, we can make the services adjusted for our needs. Again, it's not always possible to use the monolith solution and adjust this solution into our needs, because we quite different organization. We have very different units working in different areas and using different technologies. Second thing is they enable digital teams or provide self-service. And it's also very connected to the next one, accelerate by removing dependency. We're trying to give or provide to our users the tools and solutions they can control it by self with minimal as possible dependencies. It's not possible, of course, in some cases, but where is it possible, we're trying to remove ourselves at least from the chain of changes and adaptations. And the last but not least, don't rule. It's not a good idea to force someone else to use some solutions or technologies or processes, you always will find some unhappy users or even unhappy units, and the performance maybe will not be at best in that case because they force it to use something they don't like. And it's quite often you can hear like, we don't like your tool, we like this and this. So from our side, we're trying to make the service and the product, we're trying to enrich it with something else, not only the documentation, it's available out of the box or over internet, but we also build something inside. Templates, some guidelines, recommendations, demo. So our users, they learn through this demo, through these examples or templates. They learn how to use these solutions, and then they start using it, really start using it by self, because they start thinking, okay, maybe it's a good solution. We can see how we can solve this and this. So this is very important to give something more, some additional value to the customers, internal customers, so they will start using it by self, not forcing. And here it's our stack. So as I mentioned, we provide services or products in different areas, from logging and monitoring up to planning. So as I mentioned, we use Elasticsearch stack, we use Influx database and tick stack, IBM Netcool Insights, and Grafana in the monitoring area, some other tools, and we run our environment in Azure Cloud or on-premise, depending on the solution and the tools. We use containers and some automation. And today I will focus mostly on the tick stack or Influx database, how we use it, how we build self-services. And of course, I will talk about different and other solutions, because as I mentioned, we have integrated these tools together to let users end-to-end journey from collection up to alerting or testing and so on. And the question is why we choose Influx database and tick stack over other solutions. And I would say it's the better to say why modern but not the classic. And I refer as a classic solutions, monitoring solutions, as for example, you can think about Tivoli monitoring, Negius, Zabbix. This all the classic monitoring software, which is solving the monitoring area. And if you talk about Influx database and tick stack, it's defined as an integrated set of open source projects to support your metric analysis needs. And from this point, it's a mindset change. You should stop thinking about the monitoring as is, but you should think about metric analytics or analytics in overall. Because this Influx database and tick stack, you will receive quite a big amount of data, and then you will apply some alerting rules, some analysis, aggregation, and so on. And it's quite different from the classic monitoring solutions. Then you apply the alerting rules, and then the data start collecting and processing. So what is a tick stack? As I mentioned, it's a set of open source projects. First of all, data collection, Telegraf. This is a plugin-driven data collector or agent. If I remember correctly, it was about 200 plugins, integration plugins for Telegraf. So with these plugins, it is possible to collect different measurements or metrics from the systems. It can be databases, system statistics, and some applications. So quite big difference, choice of the plugins. The next part is the core part, is the Influx database itself. So basically, InfluxDB, it's a time series database optimized for the time-stamped data. On top of this, we have Chronograph, the user interface. Then you can, in the Chronograph, using Chronograph, you can explore the data in Influx database, and then you can also manage and control the tick stack itself. And the capacitor, very important part of the tick stack. The capacitor, it's a streaming data processing engine. And by using capacitor, the users can define the custom logic, how to process data. And one of this customization or processing would be alerting. The users can define triggers and some certain conditions to trigger an alert. It's also possible to use capacitor for machine learning, anomaly detection, and some data processing like aggregation. So this is a tick stack, but in our organization, in our team, we use, I would say, extended tick stack. So on top of that, we use also Grafana, and the Grafana connected to different systems, including Influx database, Elasticsearch, and some other databases or data sources. So the users, they can build dashboards using the data available in all these data sources in the same screens, in the same dashboards. Even more, we let users to connect their own databases, for example, so they can mix the data from centrally managed storage like Influx database and their own personal, I would say personal data in their own database. And the good thing, or maybe a perfect thing of this setup, we use Influx database as a shared service across organization. So whenever users start collecting data using Telegraf or third-party integrations, this data becomes available to everyone who is using Grafana or Chronograph. And let's say if database team or hosting operators, they do collect some metrics from databases or servers, this data can be used by other users who is building and creating dashboards in Grafana, and it's very quick, and they don't need to wait until we change something, we provide access, and so on. And of course, customization, custom agents or third-party agents, some integrations, we support our users with that integrations, but there is a little bit a different setup. We used to build these integrations in the past for the users by the change request. So let's say they need integration with the sub-platform. So we would come and find a solution. With this new setup, we let users manage the Telegraf or other agents by self. And we help only to bring like knowledge or information, some kind of documentation and templates maybe, but the actual ownership of the Telegraf agent or custom scripts and integrations will be on the user side. And because of that, they will build better integrations, they will improve it because they use it and they know how to integrate or collect the data from their own systems. And the quality of data collection will be improved significantly, because if the central monitoring team will do that, we don't know the client systems, we don't know your user systems quite often. So long and I would say painful process, then we build this integration. But users, they know their own setup and it can be done very quickly. A little bit more about how the data stored in Influx database or time series and how it differs from the classic monitoring solutions. So usually in the classic environment, you would have the object database. Then, let's say, server will be one object, and the network interface attached to that server will be another object. So you will have a lot of connections, and because of that, the agent on the client side should be registered in the system. Then you start monitoring. This influx database or time series in overall, it will be a bit different, or maybe not a bit, but yeah, very, very different, because the old data is stored as a data streams, the time series or streams or series, and all unique stream will have its own unique labels or tags. So in this example on the screen, I have 3 tags: the location, environment, and application name. So the combination, the unique combination of the tags or labels will give me exact data stream. So there is no more objects. It's all about the streams. And I can, by the query, the Influx, they do support SQL-like queries. This right query, I can extract the data I need, and then I can form, I would say, virtual objects. Like in this case, in this example, I group the data stream by application name and location. So with that, I will have 3 unique streams of the data. And these streams I can use for monitoring purpose as well, to detect if there is some criteria reached. So this is very important for users, again, to understand the concept and this change. And I would say it's maybe most difficult part of this transformation from the classic to Influx database, because users, they tend to think about objects. They still trying to find, I don't know, the object like a server or network card, but there is no more objects. It's very important because it will be a stream of CPU utilization. It will be a stream of memory utilization from the specific host or from network device, but it will be like separate streams. And yeah, as soon as I start talking about data streams, the first thing is data collection or gathering. So how we let users to gather, collect the data. So basically, we offer 2 main methods to deliver data points to Influx database. The first method we offer, it's API management on the 3Scale platform. So we did publish Influx database API interface through 3Scale platform. And users, by using self-service portal, they can generate the authentication token by subscribing to that service. And then they can use that token or key to configure data collectors or agents. So they point these agents to API interface. They use this authentication key, and that's it. They can collect metrics in Influx database, nothing else. It's a very quick and easy step. The only connectivity is needed to this API endpoint. It works over HTTP, so easy and fast. The only disadvantage of this method is there is no buffer, data buffer on this case. So if there is network errors, issues, connectivity problems, the data will be lost, because on the Telegraf side, the buffer for the metrics is very small, so the data will be not buffered, and then the users will lose some data. And because Influx database, it's not anymore just a monitoring solution, but it's also analytics, and it's used in our organization for some statistic and analytics. The users, they also need to deliver that data, do not lose the data. So if it's important for the users to deliver everything without any gaps in the trends and so on, we offer Kafka gateways. We deployed Kafka cluster across Volvo Cars network zones. So users can configure agents to send data to Kafka brokers. Telegraf agent, for example, natively support this Kafka brokers, so we can send the data from Telegraf to Kafka. We also have data movers, the bunch of telegraphs running for one purpose, move the data from one cluster to another, and then by doing this, we deliver data to Influx database. In that case, users even don't need to have an authentication key. They just install and configure Telegraf agent or any other agents and send the data to Kafka cluster. Again, network connectivity is important, of course. And then they can choose which method they use. We suggest to use Kafka gateways quite often because on the Kafka we can have a buffer of the data if there is some network issues. And I mentioned it, the users can use not only Telegraf agent, but other agents. And the reason is, if we think about the classic solutions, again, like Tivoli monitoring, Negus, Zabbix, they do provide many integrations and data collectors out of the shelf. And in our case, for example, we lack of Oracle database connectors for Telegraf. It can be some custom solutions, scripts, or some generic plugins can be used to gather the data from Oracle database, for example. But sometimes the users, they don't want to develop this custom integrations, or they don't want to use some customizations, and they would prefer to use some other agents to collect the data from the systems they have. Or let's say some serverless application they run in the cloud application. So they let users to run any agent they want. The only thing is they should support the protocol and data format which is supported by Influx database. And even more, they can add some metric reporter in their own application code, so the application will report the metrics to Influx database, so the agent they don't need anymore. So yeah, this is about data collections and the connectivity we provide for our users. And again, as I mentioned, self-service is a key. That all these methods, API management or Kafka gateways, they do not require any attention from our side. They don't require any approvals or anything like this. It's all automated through self-service portal. And as I mentioned, we support Telegraf as a standard data collectors or agents. And for this, we also help our users to get started. So we developed Ansible role for Telegraf deployment, and the users, they can use Ansible role or they can use their own preferable way of installation. It can be even pre-built image, pre-built agent in the operation system image, and so on. They also developed jumpstart configuration packages. So basically, the Telegraf is single binary, and then to configure Telegraf, the users, they can download configuration package from our repository, let's say base configuration for Linux API. They will replace a key in that configuration file, and that's it. They can start collecting the metrics from the host, from the Linux host. And same for different platforms and different transport methods. And they also provide some recommendations and guidelines how to make this, I don't know, flexible, and how to isolate different configurations from each other. In this example, I have the telegraph.d folder, and Telegraf will read the all configuration files from that folder. And if we have separate files which will keep configuration to collect metrics from application A and B, it will be separate files, and these files can be owned by different teams. Let's say the server virtual machine is shared across some applications. Quite similar it can be for Kubernetes cluster and so on. So the users, they can be isolated, and if they even need to update the version, the binary will be replaced. Maybe output configuration will be also updated, but the collection from the application A and B will be the same and not changed, and so on. So as I mentioned, we do provide something more related to our organization and to our way of working to the users to help them to get started and start using our products. And then we have this data collected. The next part is visualization and alerting. I will skip visualization part because the Grafana we use for dashboarding is quite well known, I would say, and it's easy to use. The Influx and Grafana have input plugin or data source plugin for Influx database, works very well. So the users, they build dashboards, quite advanced dashboards in Grafana using Influx database as a data source. And the alerting, we built a quite special setup, and we did this to help users, again, to operate it by self with as small as possible intervention from our side. So as an event routing tool or solution, we have IBM Netcool Operation Insights, and IBM NOI is integrated with many different alert or events sources. So in the central console in NOI, we do some correlation and filtering in order to help users to get the health information based on the different data sources. So all these alerts or events will be also stored in Elasticsearch index for the analytics and historical trends. And we also can create tickets in ServiceNow by automation. And we also published IBM NOI interface, API interface in the 3Scale platform. So again, similar to data collection, users using 3Scale self-service portal, they can subscribe to event management service, and they will get an authentication key and connection string. So in the capacitor, then they create alerting rules. They can use this key and connection string to send alerts to NOI. And these alerts will be correlated and displayed in IBM NOI console. Of course, users also can use other methods, notification method like email notifications, Microsoft Teams, or other notification channels. But this 3Scale and IBM NOI integration, the users also can create tickets automatically. And we provide some blueprints and templates, alerting templates for the users to help them and to educate them how to use this solution, how to create tickets automatically, and so on. So we have some examples, we have some blueprints and repository where we keep all these templates for alerting. And again, this is very important because the data stored in time series database in a completely different way. The users, they need to think about the tags. So we developed tagging strategy to let users name the series in the right way. And because the database is shared across organization, it's very important they use the common names or common tags for the data. And by doing this, by following this tagging strategy, the different teams, they can use the data provided by other teams. They can group the data in virtual objects. In this example, group by region, for example. So whenever one or another application becomes red in specific region, the users will receive the alert message saying this group or this location in critical status. Or maybe they can change it and the alert will say also the application C in the red status. So this is very important to have the tagging strategy in place. And again, we not force them to use it. The users still able to use their own tags, because sometimes the situation may be very different or maybe kind of unique for specific unit or specific team or specific application. So we don't force them to follow the tagging strategy as is. They allowed to have their own tags as well. And it helps us to get them onboarded, to get started, and maybe over time they will find another way and then they will adapt to our tagging strategy. We also give them some knowledge sharing sessions, and we provide, as I mentioned, templates and blueprints so they can just start using the existing and extend if they need. And here is an example of alert rule in the tick script language. So in private capacitor, the users they can use graphical interface in chronograph, but it would be pretty simple alert rules. And if they need to have something advanced, including after ticketing, they can use additional parameters or meta information to let NOI know if the ticket needs to be created. In this example, in the bottom, you can see the details section. So whenever alert triggered, then certain threshold reached. The alert will be sent to NOI, and the details section will be attached to that alert as a meta information. And in this example, ticket flag is equals true, meaning Netcool operation inside will try to create an alert in ServiceNow. Oh, sorry, alert ticket in ServiceNow. The priority of this ticket will be 3, and it will be routed to DevOps enablement team automatically. And because the users, they control their own tick scripts or alert rules, they can change these parameters whenever they need. Let's say they deploy a new application version and they need to adjust thresholds, or after ticketing, they can do it by self. And they, of course, suggest users how to keep versioning, how to use repositories to keep these scripts. So now they also can have a version control over alerting rules and revert back changes if they need. And how we build this design and architecture of tick stack. So here, the tick stack at Volvo Cars, I already mentioned the data collection part. They use Treescale and Kafka clusters to deliver data. In the middle, we have ingest telegraphs, the fleet of telegraphs which will receive the metrics collected by the clients, received from Treescale and from Kafka clusters. And then it will replicate exact same data into 2 environments, production and development. And they did this to help users develop and test their own alerting rules or data aggregation and processing rules. Because quite often, if you have separate development environment, you quite often don't have enough data, or you send just a few metrics in that development cluster, and you're not able to see how it will behave in the real load, in the real situation. So we decided to split the data into 2 environments, exact same environments, production and development. And we deploy dedicated capacitors for each organization or for each team. The reason is we have dedicated capacitors because the capacitor itself is not tenant aware, I would say. And if the users, they have access to edit alerting rules, all users, they'll see all the scripts created by other members. Meaning if they have many different teams working on the same capacitor, it will be kind of a mess. So we decided to isolate the teams by separate capacitors. We call these private capacitors. So the users, they can develop and test their own scripts. And if they're ready for production, they also can add additional meta information in that alerting rule or data processing rule. And tick replicator function we run on Azure Functions will recognize that scripts or rules, and it will synchronize the changes into production capacitor cluster. So by doing this, we isolate dev environment from production, but let the users use the exact same data on both environments. And on top of that, we use the voucher instance, the open source version of Influx database and capacitor to monitor the environment. And it's very easy to write something strange, so performance of Influx database will be affected too much. So the voucher will recognize if the health of dev environment is good and the state is green. But if something goes wrong, the voucher will recognize the situation and will raise a flag for mover or for replicator function. So it will stop replication from private capacitors up to production capacitors. By doing this, we will block the changes and the production environment will up and running all the time. And then the user fix the issue, or we found some other problems maybe and fix it in dev environment. The flag will be removed and the tick replicator will start synchronization again from private capacitors up to production capacitors. So again, a lot of done to let users to manage and maintain their own setup by self. These as small as possible actions from our side. I didn't mention before, in Influx database, we basically have two databases in each environment, the short-term database and long-term database. We did this setup to make the data stored for longer period of time clean and not very messy, because as I mentioned before, the users, they can decide what kind of information they want to receive. They develop their own integration plugins, and sometimes, for example, the measurement or metric name can be corrupted, maybe some misspelled or anything else. And this data will be received and stored in the raw, as a raw data in the short-term database. We also have permission list. Basically, the permission list is a list of fields or measurements we need to replicate from short-term database to long-term database. In the short-term database, I didn't say we keep the data for 24 hours. Long-term database, I think 3 months as of now. So our customers, our users, they can update repository with new measurements if they decide they need this in the long-term database. Our team, we will review the changes. So basically naming convention, and if there is good to have it in long-term database in terms of naming convention. And then we have some automation pipeline. So the tick script for ingest capacitors, the data movers will be generated and updated in the production and dev environment. So again, the users, they will get their own new configuration very quick, in just Usually it's a few minutes, and then the data stored in long-term database as well. And the users, by using capacitors, they can use the short-term database for alerting purpose if they want to, or long-term database for alerting and for analytics purpose as well. And the private capacitors, we use blue-green deployment. They basically will use AKS clusters to host private capacitors. They use application gateway and traffic ingress controller to route the traffic to private capacitors. As I mentioned, we have plenty of different teams using capacitors, so we have plenty of services. We also deploy the Telegraf and FileBit to collect metrics and logs from the clusters and from private capacitors as well. And we build dashboards to display the status of capacitors. So users, then they develop their own scripts or alerting rules. They can also see logs and debug their own scripts. And they use shared storage in Azure in order to migrate capacitor services from one cluster to another. Then we need to upgrade AKS cluster or test new version or configuration, for example. And we operate everything as a code. So we have repository. The users, our users, they also have access to this repository. So if a new team, they need to have private capacitor, or existing team, they need to have additional private capacitor for their own needs, they can basically copy paste the module in the code and make a pull request. So our team again will review the changes, and if everything is fine, we will just accept this change, and Terraform will deploy or update all artifacts we need to run private capacitors from application gateway and DNS records. It will generate authentication keys and so on, and it will update and deploy the private capacitor services and traffic rules. So again, it's about self-services, and the users can get the new private capacitor in about 10-15 minutes maybe. And yeah, finally, classic VS modern monitoring lifecycle. This new approach, this influx database, as I mentioned, you should think, the users should think in different way, and we ourselves also got these changes in our mindset, because there is no more objects in the monitoring system. So in the classic system, if you need to have new rule or graph, you will create new template or maybe update the existing template, assign this template to group of objects, maybe Windows servers, for example, or group of applications. Then the agent will discover the new configuration, apply these changes, and will start reporting the metrics you need, and they'll start monitoring some metrics and certain conditions. So you will have new dashboards. This is the data reported by agent, and the alerts, of course. In the, I would say, the modern approach, the agent, the Telegraf agent or another agent, will collect all metrics, maybe not all, but most of the metrics by default. So you will have the bunch of measurements or telemetry already reported in the Influx database. From the beginning, you probably will not use this data for alerting or dashboarding. But quite often, probably you remember the situation, you have some big problem on the application, some downtime, and you don't know why. So you start investigating in the monitoring tools, and you see like, okay, I missed this and this metric, and I guess it was because of some network issue. So you will configure this template and start collection of metric telemetry. this Influx database and Telegraf agent. All the metrics ideally should be collected from the beginning. If you use this configuration package and default plugins, all these metrics will be already in Influx database. So whenever you have the problem in your application, you can go back in the past and maybe explore the data, or maybe create a new dashboard or add some trend in order to investigate and see the correlation between different graphs and trends. And then, of course, you can apply the monitoring rule, and you don't need to wait until the next issue happens. And also another thing is, because there is no objects anymore in the modern, or I don't know, DevOps-oriented solutions, such as Influx database, if we think about containers, your application may scale up and down all the time, daily, hourly. So new containers will pop up, and then if you need to monitor what is going on inside of the containers, in the classic monitoring solutions, it will be hard to manage this, because each container is its own unique ID need to be registered in the system. Then it need to be deregistered because it does not exist anymore. And it's a lot of maintenance work. It can be automated, but still a lot of registration and deregistration actions. In some solutions, you might need to pay for each and every object, and it can be very different. In the Influx database, you don't care basically, because there is no more objects. So let's say you have an application A running on the containers, and then each and every new container pop-ups, it will start sending the stream of the data. Let's say, I don't know, number of users landed in this specific container, or number of network connections, I don't know. And this measurement will have two labels, the application name and container ID. So you can easily recognize the container, which is failing, for example, or maybe overloaded, and the application name. And if this container dies, you don't care anymore. The data will be wiped out from the system, from Influx, after retention period completed. So it's very adapted to fast-moving pieces. And again, this is changing mindset. I see it quite often. The users, they try to find like how I add new object or new server in the Influx database, but you don't need. You just need to think about alert rules and the tagging strategy. So with that, we're trying to solve and answer on these three major points: the transparency, the mindset, and self-service. And Influx help us to bring transparency, and by this setup, we enable users to use the solution to build dashboards and alerting rules by self, and we help them to change mindset. In my opinion, maybe it's the most difficult part, the mindset. The users should start thinking in a different way. So we have some internal events and documentation or templates, as I mentioned. So with that, I would say thank you all for listening, and I would be happy to answer on the questions if you have some.
All right, great. Well, we have, what a great presentation. Thank you so much, Maksim. We do have time for one, maybe two questions. So if you do have a question for Maksim, go ahead and use your GoToWebinar control panel and submit it now. Here's a question for you. How do you currently monitor your open source components, and how do you identify and remediate open source vulnerabilities within your software development lifecycle?
So basically, as I mentioned, in our setup, if we talk about tech stack, they use the open source installation of Influx database and private and Capacitor. So we have self-monitoring for our tools using the same technology, but it's totally separated to make sure if we have problems on the main installation, on the main cluster, it will not be affected and we will be notified. Our users, they use Telegraf agents and they use our service. Some teams, they use, as I know, the Prometheus exporter, because it may be they used to use it and it may be have not maybe but have good support for EKS clusters, so they can report the data using Prometheus exporter but send data to Influx. So yeah.
All right, great. Let's see, here we go. Here's a question for you. Why did you choose InfluxDB over Prometheus?
Yeah, we had a look into both solutions basically, because both can provide, they're both basically time series and both DevOps oriented and Agile oriented, I would say. But for our case, it's very important to have enterprise support. So we built enterprise license for Influx database, and we got the support from the vendor from Influx Data. So this was one of the key factors in our case why we choose Influx over Prometheus.
All right, okay. Well, we are about 4 minutes to the top of the hour, so unfortunately that's all the time that we have for the question and answer period. If we didn't get to your question, I am very sorry, but please know that the folks at Influx will be getting a copy of all of the questions that came through, so I'm sure that they'll be more than happy to work with you to get a question, get an answer to your question. I also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did mention at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and get to that. Our first winner today is Jason E. Congratulations, Jason. Our second winner today is Mari G. Congratulations, Mari. Our third winner today is Stephen R. Congratulations, Stephen. And our final winner today is Robert F. Congratulations, Robert. We'll be following up with all 4 of you offline to get your $25 Amazon gift card over to you. So check your inbox. If you don't see anything in your inbox, please check your spam filter. Maxime, thank you for a very interesting presentation. Really appreciate your time and your expertise. Really, really fascinating case study. So thanks again. Really appreciate it.
Thank you very much.
Great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.